Hello everyone, in this video we'll go through the basic concepts of 7 quality control tools and the PDCA. So 7 quality control tools are 7 different tools which are very simple to use and provide you a way to visualize and analyze the process and process related data so that we can rectify or reduce the problems within a process, right? So problems such as quality problems here. So very first one is process flow diagram. So we already used various types of process flow diagrams in the previous chapters, such as process flow chart, service blueprint, right? So you can use process flow diagram to visually understand the process. For example, for a assembly line for a car manufacturer, these are the areas where the inspection is happening, right? If the quality problems are increasing, you may want to focus on these areas in order to identify why you have more quality problems, right? The next tool is check sheets. So once you know how your process operates, then you can start collecting data, right? So check sheets allows you to collect and organize data by problem categories, right? So here first column represents the defects, and then you have days represented in the second row, right? So with respect to each defect, there's some data being collected, right? So we'll look into 2 different templates of check sheets through our example in next video. The third tool is histogram. So histogram allows you to study the empirical frequency distributions. You can get this information from check sheets too, right? But it's always better to represent data visually so that you can understand where the majority of problems are happening, right? So by looking at this histogram, we can see that we have one peak around type C defects, right? Similarly, you may have a histogram where you have 2 peaks, right? So again, this is the visual representation of the data that we collected here using check sheets. And always remember, visual representation is very important. So the next tool is the Pareto chart or the Pareto analysis. So Pareto analysis allows you to focus on most important problems, right? So we use in this case what we call 80-20 principle. So based on this principle, 80% of problems are caused by 20% defects, right? So it's better to focus on these 20% so that I can rectify 80% of the problems instead of solving these problems which will have very small impact, right? So we want to focus on where we can have a bigger win, right? Okay, the next tool is cause and effect diagram. So other names for Ishikawa diagram. So Ishikawa diagram or the fishbone diagram allows you to organize the possible causes of a problem. So under fishbone diagram, you can organize the causes into 6 key categories. These are also known as 6M. So that will be the term you may come across in industry. So which means causes due to material, method, environment. This is also referred as Mother Nature. Measurement, so which is method of measurement. There could be flaws in a system when it comes to measuring the quality problems. So the wrong measurement method could increase the problems in a system. Similarly, due to people, which is also categorized as men. So lack of training, new employees, alright, so all those could be associated with people. And equipment, so which is machines. So under machine, you can think of such as old machines, inappropriate technology, inappropriate tools for a particular job, right? So which can lead to quality problems. So when you develop a fishbone diagram, it is always a team effort. You go through a brainstorming session in which you identify these causes related to the problem. Sometimes you need to go and do the visual inspections. You need to go and observe the process, right, in order to collect this data. Then you get back to a team and then you put these causes together, right? Okay, so the next tool is scatter plots. So scatter plots or the scatter diagram allows you to understand the degree of relationship or the correlation between two different variables. So the three possible outcomes of this: a correlation between two variables could be positive, negative, or no correlation. Right? Okay, so in order to understand this, let's take one hypothetical example. So let's say along y-axis we have number of quarterly problems, and along x-axis the number of hours an employee worked without taking a break, right? So between these two variables, there are likely to be a positive correlation, as we have a number of hours increasing without an employee going on a break. So you're expecting a positive correlation here, right? So how it will work, so you may have a hypothesis that as we don't send employees on break, the number of quality problems will increase. So you go and collect data on when employees go on a break, right? So that will give you your X variable. Then collect the quality problems on hourly basis, right? So you can use check sheet for that. That will give you Y variable. Then plot these two variables, right? And then you can see if there's a correlation or not, right? Similarly, the other example would be for a negative correlation. Again, let's say quality problems along y-axis, along x-axis, let's say years of experience. So your hypothesis would be that more years of experience, you're expecting less quality problems. You're expecting a negative correlation here. So which means when years of experience increases, the quality problems tend to decrease. So both of these variables are going into opposite directions, right? So again, the process will remain same. You will set your hypothesis, go and collect data on years of experience and quality problems by those employees, right? So you can use check sheet to collect this data, where you collect data maybe on weekly, daily, or monthly basis, right? The next tool is control charts. Control charts allows you to differentiate between special cause and random cause variation. So for any control chart, you're going to have upper control limit and lower control limit, and a central line, right? And this blue line is representing the observations from your process. So if your observations are within upper and lower control limit, right, we call this random cause variation. So random cause variation is due to the randomness of the process, right? So usually this type of variation can be reduced by improving your process, by doing process re-engineering, and so on. On the other hand, if you have a data point, let's say a data point is here outside the control limit, either upper control limit or let's say the lower control limit, that is due to a special cause variation. Sometimes we call it assignable cause, so which means the variability which happened in this process can be assigned to a specific instance, right? We will not go through how to determine upper and lower control limit at this point. That will be part of the next chapter, where we set up the control limit for the control charts. But at this point, the only idea here is how the control charts work, right? Okay, so just a quick note on the PDCA cycle. So PDCA cycle, also called Deming's quality cycle. So most of the companies will use this in a continuous improvement projects. So we always start with a plan phase. So that's where you will identify what needs to be done, what needs to be improved, right? So you can use various tools such as flowchart, check sheets, histogram, Pareto chart to understand which area you should focus and develop your improvement plan accordingly, right? So in do phase, you go ahead and implement those changes, right? So you may select a small production area where you roll out these changes, and after rolling out changes, you can collect more data and see if the changes were successful or not, right? So again, if the changes are successful, then you will go ahead and roll it out for the entire production floor or for the whole factory. Otherwise, you go back to the planning board and revise the solution and perhaps collect more data and so on. So you always keep on going in this continuous cycle. So that's why it's called continuous improvement cycle, right? Okay. So here's some information, different tools which can be used for the plan, do, check, and act phase. So have a look at these. Okay, so for this particular part, we'll stop here. If you have any questions around PDCA cycle on the quality control tools, please feel free to reach me out. And I will see you guys in the next video with the example of PDCA tools.